Hello everyone, in this video we are going to learn about the measures of central tendency. Three commonly used measures of central tendency are mean, median and mode. We will learn to find the mean, median and mode for ungrouped data first. Mean is the most important measure of central tendency. It is denoted as x bar and is equals to the sum of all data x divided by the number of data n. For example 1, the number of data is 11 and the sum of all data is 154. So the mean is 154 divided by 11 and equals to 14. For example 2, Nina buys 8 tins of soup. This means that n is equals to 8. 4 have mass 400 grams, 3 have mass 425 grams, and 1 has mass 435 grams. This means that the sum of all mass is 3,310. So the mean is 3,310 divided by 8 and equals to 413.75 grams. Median is the middle value when the original data values are arranged in descending or ascending numerical order. In general, with n observed value arranged in order of size, the median is calculated as follows. If n is odd, then the median is n plus 1 over 2 ordered value. If n is even, then the median is the average of n over 2 and n over 2 plus 1 ordered value. For example 1, we rearrange the data from the lowest to the highest or in ascending order first. Since the number of data is 11, which is odd, so we use the formula n plus 1 over 2. And we know that the median is the 6th observation. The 6th observation is equals to 13. So the median is equals to 13. For example 2, it is already in ascending order. Since there are only 6 data, so we know that the median is the average of the 2 data in the middle, and it is equals to 19. Mode is the value that occurs most frequently. The mode may not exist, and even if it does exist, it may not be unique. That means the data may have more than one mode. For example 1, there is no data that occurs more than one time, so there is no mode. For example 2, 4 and 7 occurs most frequently, so the mode is 4 and 7. For example 3, 9 occurs most frequently, so the mode is 9. And for the last example, 1, 2 and 3 occurs twice, so the mode are 1, 2 and 3. For this example, the table shows the distance traveled to work by 150 commuters, and we want to find the mean, median and mode rounded to the nearest kilometer, which means the answer must be in whole number. In order to solve for mean, median and mode, we have to complete this table first. We know that the total frequency is 150. The column fx means that we have to multiply the frequency f with its corresponding x. So for the first category, it is 12 multiplied by 5, which is equals to 60. The next one is 23 multiplied by 10 equals to 230. And the rest are this value after we multiply f by its corresponding x. And the total of fx is equals to 2695. The cumulative frequency are this. Mean is sum of fx divided by n, where n is equals to sum of f. Substitute the values from the table and we get 17.97. But since the question want the answer to the nearest kilometer, so the mean is 18 kilometer. Since the number of data is 150, which is even, so the median is the average of the 2 data in the middle, which are the 75th and 76th observation. To find the data, we refer the cumulative frequency. 12 here means that the first 12 data are 5. The 13 to 35th data are 10. The 36 to 80th data are 15. That means 75th and 76th are both 15. So the median is equals to 15 kilometers. The mod is the value that occurs most frequently. From the table, the most frequent or the highest frequency is 45, where x equals to 15. So the mod is 15 kilometer. Now we are going to learn to find the mean, median and mod for group data. The total frequency is 123. The class midpoint is the average of lower and upper limits. The fx is the multiplication of frequency with its corresponding x or midpoint. The total fx is equals to 729. The cumulative frequency for the first interval is equals to its frequency 20, and for the next intervals, just add the frequency of that interval. To find the mean, we substitute sum of fx and sum of f into the formula, and the answer is 5.93 years. The formula of median for group data is given as this, where L sub m is the lower boundary of the median class, f sub m minus 1 is the cumulative frequency of the class before the median class, f sub m is the frequency of the median class, and C is class size. For group data, we had to determine the class median first. Since the middle data is 61.5 observation, so it lies in class median 3 to 5. From here, we can also get the lower boundary of the class median, which is 2.5. The cumulative frequency before class median is 20, and the frequency for this class is 43. The class size is the upper boundary 5.5 minus the lower boundary 2.5, and it equals to 3. Substitute all the values into the formula to find the answer. So the median is 5.40 years. The formula of mod for group data is given as this, where L sub MO means the lower boundary of the modal class. D sub 1 is the difference between the frequency of the modal class and the class before. D sub 2 is the difference between the frequency of modal class and the class after. C is the class size. To find the mod, we must determine the modal class first, which means the class with highest frequency. From the table, the highest frequency is 43, so the modal class is 3 to 5. From this table, we can also find D1, where D1 equals to the frequency of the class 43 minus the frequency of the class before, which is 20, and it equals to 23. D sub 2 is 43 minus the frequency of the class after modal class, which is 37, and it equals to 6. And the class size is the upper boundary minus the lower boundary, and it equals to 3. Substitute all the values into the formula to find the answer, and the mod is 4.88 years. We can determine the shape of data distribution by comparing the values of mean, median, and mod. There are 3 shapes of data distribution. The first one is symmetrical. The graph is a bell shape where the value of mean, median, and mod are equals and lie at the center. The second type is positively skewed or skewed to the right. From the shape of the graph, the value of the mean is the largest, the mod is the smallest, and the median lies between these two values. The third type is negatively skewed or skewed to the left. From the shape of the graph, we know that the mean is the smallest, the mod is the largest, and the median lies between these two values. In this example, we want to find mean, median, and mod, and then determine its shape. We had to complete this table first in order to find the mean, median, and mod. To find the midpoint, we add the upper limit and lower limit and divide by 2. For the column fx, we multiply the frequency f with its corresponding midpoint x. And the cumulative frequency for the first class interval is equals to its frequency 8, and the rest are this. Total fx equals to 18,152.5. Mean is total fx divided by n, or the total of f. So the mean is Rm 279 ringgit and 27 cent. The answer must be in Rm. For median, it is the 32.5 observation. So find the median class first. In order to find the median class, we have to refer to the table. 32.5 lies in the class interval 270 to 279. From this class interval, we also know that the lower boundary of the class is 269.5. The cumulative frequency before the class is 18. The frequency of the class is 16. And the class size is equals to 10, which is the upper boundary minus the lower boundary. Substitute it into the formula of median and state the answer, and it must be in Rm. The correct answer is 278.56. For mod, we had to find the modal class first, which means the class interval with the highest frequency. So from the table, the highest frequency is 16, so the class is 270 to 279. From the table, we can also get the D sub 1, which is 16 minus 10, and D sub 2, which is 16 minus 14, and the class size is 10. Substitute all the values into the formula, and we get the answer. From the values of mean, median, and mode, we know that the smallest value is the mode, followed by median and mean. So the data is positively skewed, or skewed to the right.